Resolving forces into components. This means you have got a force that is acting at some angle. So that means it will have a magnitude or a size. That could be something, a number, either large or small. Also an angle that it makes with either the vertical or the horizontal. Now, what resolving means that you are taking a force at an angle and you are splitting it into two forces that are at right angles to each other. So you'll be taking this force and you'll be splitting it into its horizontal and its vertical components. Now, if we take a different colour and just add in our original force, we can see that when we put them tip to tail, we get exactly the same result. If we are resolving forces, what we need to do is we need to find the size of the component of that force that acts horizontally and vertically. That means you are going to have to resolve this. If you label on the sides, this is a right angle triangle with a right angle here. That means that this is our hypotenuse, this is our opposite, and this is our adjacent. That lets us work out the size of this. So you may know from SOHCAHTOA that the sine of your angle and the cos of your angle are equal to things divided by the hypotenuse. This side here is going to be given by cos of our angle, which is 32, is equal to the adjacent, the thing we want to find, divided by the hypotenuse. So that gives us that A here is going to be 100 times cosine of 32. This side here, you can see that sine of our angle is equal to the opposite divided by your hypotenuse. We want the opposite angle, size of that, so we've got O is going to be equal to 100 times sine of 32 degrees. Make sure that your calculator is in degrees. And not radians. You can usually check, because if it is in degrees you will see a small d at the top of your screen. If it is in radians you would see a small r. Now, this method also works when you have forces that are measured relative to the vertical. Once again, if you take your original force arrow, you can see we can split that into a force that is acting vertically and a force that is acting horizontally. Similarly before, you can mark on your sides. This is now next to, so that would be the adjacent, that would be the opposite. You may note this bottom one here would be given by 250 sine of your angle. This vertical component would be given by 250 cosine of your angle. You may notice that it is not sufficient to say that the horizontal component is always cos or sine. You actually have to look at the situation you've got. If you were trying to actually communicate what you have worked out, you would make sure that you say that what the vertical component and the horizontal components would be. So here our vertical component would be 100 sine of 32, which you could put into your calculator to find out what that would be. It comes out about 52.99 newtons, which you would round to a sensible number like 53.0 newtons. Your horizontal component of this force here would be this 100 cosine of 32. A common mistake that students may make is actually to get these mixed up with their sines and cosines. That is why it's important to label on and to learn your trigonometric identities.